In the tutorial on hydrates, we learned that hydrates are a type of ionic compound that have water molecules associated with them. And so in the question that we have here that we're going to look at is we've got 3.34 grams of a sample of a hydrate, and we are told that the hydrate has this general formula. We know that we have this much of the anhydrous compound. We need to determine the value of X, or we need to determine the number of water molecules associated with each one of the SrS2O3 molecules in this ionic compound. And so all of the given information is recorded here, including what was given explicitly in the problem, and then some things that will most likely be useful, including the molar mass of the anhydrous compound and the molar mass of water. And as I mentioned before, we are trying to find the value of X, which is the number of molecules of H2O associated with the SrS2O3. And so really here, a good rule that we've talked about in doing any sort of chemistry calculations is to find the number of moles. And so to find the number of moles of what, you might ask? Well, any mass values that we have, we want to turn them into, or potentially turn them into mole values if possible. And so we see here, based on the given information, that we could definitely find the number of moles of the SrS2O3. The number, because we know the molar mass of the SrS2O3. We don't know the molar mass of the hydrate, because in order to know that, we would need to know how many water molecules are associated with the SrS2O3. However, because we know the mass of the hydrate and we know the mass of the anhydrous compound, the difference in the mass is the mass of the water, as shown here. And so we now have the mass of water and the mass of the anhydrous compound. We can figure out the number of moles of each of those things as seen in number 2 and number 3. And knowing the number of moles of each one of those things allows us to compare them. So it allows us to see how much water there is with respect to the amount of SrS2O3, whereas we couldn't do that with the mass values. And so a term I'm going to use is that when we find the number of moles, we can now compare, because we've sort of normalized things. We are now talking about things in the same terms. Whereas the mass values, we can't compare mass values and take a look at what that means for a molecule, or how many, the ratio of the atoms in a given molecule. But we can do that with moles. And so our next step then is to find out what that ratio of water molecules to SrS2O3 is, because that's essentially what X is, or that's what we are being asked to find in this problem. And so all we need to do is divide the number of moles of water by the number of moles of SrS2O3, and we find that it's 5. And maybe alternatively to the way that this is being shown, we could also express this answer using a mole ratio. So you'll have to excuse my messiness, but showing the mole ratio version of what we did over here goes like this. So from the chemical formula, we know that we have, for every X moles of water, we have 1 mole of the anhydrous compound, or of the SrS2O3. But we know that we have, in this situation, based on the information we've been given, we have 0.0577 moles of water for every 0.0115 moles of the anhydrous compound. And so by, quite simply, solving for X in this situation, which essentially just turns out to dividing this by this, we get 5. And so we have found then that the molecular formula, or the formula for this hydrate, is as shown here, the SrS2O3 5H2O, or it's the pentahydrate. And I guess a quick check for this to see if this answer is reasonable is, well, the X is a whole number, and you need that X value to be whole numbers, because you can't be talking about portions or parts of a water molecule. It needs to be entire water molecules. So when doing calculations involving hydrates, I think we need to remember that it's really about finding the ratio between the anhydrous compound and the number of water molecules. And that's what this problem focused on. And not every problem is like this, but it will still involve that relationship between the anhydrous compound and the number of water molecules.